Hello. Today we will take a look at an example of how to run IRIS application on Kubernetes cluster, specifically on a Google Kubernetes Engine or GKE. My name is Mikhail Khomenko. I used to work as InterSystems cache administrator. The last few years I have been working as a DevOps engineer. We will deploy an IRIS application to a Google Kubernetes cluster. Generally speaking, Kubernetes consists of worker and master nodes. Hopefully with Google you don't need to think about master nodes management. After worker nodes creation, we will take a look at Kubernetes manifests. These are YAML files describing application in terms of Kubernetes, like deployment and service. Then we will provide an external access to an application secured with TLS. All described steps will be defined in a special YAML file called GitHub Actions workflow file. During this session we will touch provisioning tool Terraform. We will look at how to install a package into Kubernetes using package management tool Helm version 3, and we will look at what GitHub Actions gives us in terms of automated deployment. We will take a COVID-19 application that pulls data from Johns Hopkins University and shows COVID-19 statistics in a graphical view. Let's fork it and run it on a local machine. That's the original repository. We are going to fork it. We already forked it into InterSystems community group. Let's clone our fork. This repository already contains some files, some deployment files. We are going to remove them and create from the scratch. Let's build Docker image first with cache disabled. As we see, deepc is used here, and let's run this container. Check this application by connecting to IRIS web port that corresponds to a host port 32916. Looks like this application works. It shows statistics across the world and in the USA specifically. Okay. After testing a local deployment, we run this application on a Kubernetes platform. We need to create a project first, then we should create a Kubernetes cluster. We will take Terraform for that. Another option specifically for Google Cloud could be a Cloud Deployment Manager. Terraform should connect to Google on behalf of a special service account with a bunch of special permissions. So we'll create such an account and then generate and download its corresponding key. This key should be placed into GitHub secret. Terraform can store its results called a state remotely in a special bucket, so we will need to create this bucket too. I've already created a project called COVID-2019 Analytics. For that I should enable Kubernetes Engine API, and for that I should enable API and billing. We can read more about API and billing on this page. Also, let's remember COVID-2019 Analytics project ID. Make this project default. Let's create GitHub COVID-19 service account. Let's add some roles to this service account, like container admin, storage admin, and so on. Let's check that this service account was created and roles were added in Google Cloud Console. Sometimes it's worth to reload the page. Yeah, as we see, GitHub COVID-19 here, and it has corresponding roles. So the next step is generation of key for this service account. This key will be called GitHub COVID-19 JSON file. We will add it into gitignore file to not store it git. And that's copy content of this file and put it into GitHub secrets environment variable. Let's create variable Google service account key and put the content of file here. Now we are ready to create Terraform files. We create several files, all ending with tf. Let's look at them. In this file, we define that we use Terraform version more than 0.12. We use plugin, Google plugin, deploy all stuff into COVID-2019 analytics project, and Terraform will save its state in this bucket called Terraform COVID-2019 analytics. This bucket name should be available, as bucket names should be unique across all Google accounts. So let's check that this bucket name is available. Okay, it doesn't exist, so we can create it. And let's enable versioning for it, as Terraform recommends. Versioning enabled. In this Terraform file, we define Google Kubernetes Engine cluster. It's called COVID-19, contains 2 worker nodes, has version 1.17. Each node is of N1 standard 1 type. As I remember, it's 1 CPU and 4 GB of memory. And in this file, we create static IP address to connect to our application from the internet. Now we are ready to deploy InterSystems IRIS application using Kubernetes manifests, and this manifest can be simply created from a Docker Compose YAML file using Compose utility. Let's look at an example. Let's create first a directory where we will store our Kubernetes manifests, and then run compose convert utility. 3 files were created, and now we are going to refine them a little. Let's use stable API in deployment. Also in deployment file, that's add selector. It's used implicitly, but in the recent versions of Kubernetes, it should be defined explicitly. And also, that said, interesting thing that will allow us to fight with zombie processes inside IRIS pod, sharing with a special pause container, sharing namespace, process namespace. Let's also refine a service a little. Declare that this service will be of type cluster IP, so it will have internal IP but won't have external IP. For external access, so access from the internet, we are going to create a special ingress resource that, in conjunction with ingress controller that will be deployed later, with this conjunction can create load balancer, and traffic to that load balancer can be redirected to this service. So let's create ingress. Here we see that request to COVID-19 murders.club, this is demo domain. This request will be directed to IRIS service on port 52773. And this endpoint is secured. Certificate is provided by Let's Encrypt, and Let's Encrypt will check our authority through load balancer. Let's add actually Nginx ingress controller and that certification manager. Both will be deployed using Kubernetes package manager tool called Helm. We won't describe Helm in details, but deployment steps we will define in GitHub Actions file. GitHub Actions is an implementation of CI/CD from GitHub. You can read more about its syntax on this web page. And let's look at implementation for our project. Workflow file should be defined on the .github/workflows directory. Let's create this directory. And workflow can be any file ending with .yaml. For instance, iris app.yaml. It looks like this. So deployment will be triggered on push to master branch. Also, as we see, several environment variables are defined, like COVID-2019 Analytics Project ID. GitHub secret is referenced by this construction, secrets.google service account key. And a workflow contains several jobs, like build and publish image, infra provisioner job. All jobs will be running in parallel. If we not define other behavior, and like in packages install job, that needs to be running only after build and publish image and infra provisioner job finish successfully. Job IRIS application deploy will be running only after all three previous jobs finish successfully. Let's take a look at jobs implementation in more details. Each job contains of several steps. Each step is running inside Docker image with Ubuntu. Checkout step pull repository. Then we connect to Google using Google service account key. Then we build an image, tagging it with commit hash, and then we push that image into Google container registry. Infra provisioner jobs install Terraform of version 0.12.29 and then run several Terraform commands like init, validate, plan, and actual resources creation, Terraform apply. Packages install job. Install Helm. Then we connect to Google. Then using Helm we install Nginx Ingress controller, and then we install certification manager. Install procedure is Helm upgrade -- install of specific package, specific version with specific variables. For these projects, for these packages, we should add special repository, and each package will be installed in its special Kubernetes namespace. In the end of certification manager installation, we install 2 instances of cluster issue resources. Let's take a look at these files. Wait a second, please. Here we see endpoint of Let's Encrypt, and Let's Encrypt will check our authority using HTTP method, and the second file, staging, is the same. And the only difference is different endpoint. And this is contact email to notify about certificate expiration. So everything is ready to be running. Let's run standard procedure: git add, git commit, git push. And let's look at deployment process. As we see, 2 jobs were running initially. Particularly in provision infrastructure job, we see steps Terraform performs to create resources. What will be created we can check in Terraform plan output. Big amount of lines, but let's scroll to the end and see that 3 resources will be created. 3 resources is cluster, worker nodes, and static IP address. I think that IP address was already created. Let's check it. Yep, COVID-19 regional has this IP. So we need to add domain name to this IP address. I'm using GoDaddy in this demo. So I go to edit management, edit DNS management for demo domain merdes.club and add this a record. Then we are going to check if this record is available for all DNS across the world. Initially check name server from GoDaddy. Yes, this IP address. And let's check root DNS server, the same IP address, and local DNS server. Okay. So this deployment initially will take about 10-15 minutes. And after that time, as we see, a Google cluster, Kubernetes cluster was created. Check it in Google Cloud Console. We can run this command to connect to this cluster. I check, for instance, list of nodes, 2 nodes, okay. And let's check our IRIS application state. I think it was not this namespace. Let's check namespace where IRIS application was installed to. If you not remember, you can simply list all pods in all Kubernetes namespaces. As we see, IRIS application was deployed into default namespace. If you want to change a namespace, you can add Kubernetes namespace creation before kubectl apply. And that's actually connect to our IRIS application through endpoint. Yes, it looks working. We see data. Cool. By the way, this statistics should be updated every 1 hour. So, okay, the most time-consuming part was finished. And what we've learned. Avoiding manual infrastructure creation gives us several advantages, like a quick answer a question what our current infrastructure consists of. Who did create what, when, and why? As an addition to this approach, it's better to not deploy application manually and leave this work for CI/CD process, specifically for its implementation for GitHub called GitHub Actions. Feel free to use another tool like Circle or Travis CI. Deployment steps defined as a code allow more people to know how exactly your cool application can be deployed. For external access, you could use the native Google approach using their ingress controller GCE and managed certificates. But we've used Let's Encrypt. As it's more this approach, our approach is more flexible in settings. And also take into account that while Google has a free tier, it's better to control their costs, especially after 1 year of usage. Next steps will be points for improvement. In this particular application, data are stored inside an image. It's worth to store data outside in a persistent disk. For that, you could use a special Kubernetes resource called stateful set. Also, it's worth to add monitoring and alerting. IRIS already provides us with a monitoring endpoint API monitor metrics with output on a Prometheus format. So you could deploy Prometheus or any Prometheus compatible solution like Thanos or Victoria Metrics. In case of IRIS, the simpler solution would be deployment of system alerting and monitoring, aka STEM. For simplicity, we didn't define hardware limits, like how much CPU and memory can be used. Also, we didn't define probes then that Kubernetes used to check if your application is working or need to be restarted. In real life, resources and probes have to be defined. Also, it's worth to have different workflows for infrastructure and application. Default user password is used, so it's worth to create custom IRIS users passwords roles. For instance, it could be done in lifecycle post-start hook during running an IRIS pod, leveraging Kubernetes secrets. Also, there is a pull approach called GitOps, when a special tool deployed in the Kubernetes constantly checks repository for changes and if finds such, triggers the deployment procedure. Examples of this approach are Flux and Argo CD. It's recommended to attend those sessions and visit these cool links for reading. That's my contacts in LinkedIn and community InterSystems. And thank you for watching.